Hello, it's Super Easy Math again. In this video, we will talk about rationalization of fraction. So let's get started. What do you mean by rationalization? It's removing square root from the denominator. So here we have 3 over square root of 5. If we want to rationalize this fraction, all what we have to do is removing this square root from the denominator. But how can we do that? Can't just we use a spray? Let's see. We said before that square and square roots are opposite. So the only way to remove this square root is to have a square here, like that. But how can we do that? Suppose that we have 3. To get a square, we multiply 3 by 3, we will have 3 square. The same for minus 5. So minus 5 multiplied by minus 5, we will have minus 5 square. If we apply this rule to square root of 5? So square root of 5 multiplied by square root of 5, we will get square root of 5 square, which is equal to 5. The same for square root of 10. So to remove this square root, just multiply the number by itself. We will get square root of 10 square. The square will remove the square root and we will get the 10. So as you notice, the only way to remove the square root is to multiply the number by itself. Let's go back to our fraction. 3 over square root of 5. So to rationalize this fraction, we have to remove this square root, and that is done by multiplying the denominator by square root of 5. But because we multiply the denominator by square root of 5, we should also multiply the numerator by the same number in order to get an equivalent fraction. So 3 times square root of 5 is equal to 3 square root of 5, and square root of 5 times square root of 5 is equal to 5. So as you notice, we have no square root in the denominator, so the fraction is rationalized. Another example. So to rationalize this fraction, multiply the denominator by square root of 7 and the numerator by the same number, which is square root of 7. So square root of 3 times square root of 7 equal to square root of 21 over 7. So we have no square root in the denominator, so the fraction is rationalized. Another example. Here we have two numbers in the denominator, square root of 13 and 1. If we multiply it by square root of 13, as we did before, we will get 13 minus square root of 13. So in this case, we still have a square root in the denominator, so the fraction is not rationalized. What we can do is multiply the denominator by its conjugate. What's conjugate? It's the same number, but here we will have a positive sign instead of negative. So just multiply it by square root of 13 plus 1. And the same for numerator. Now 8 times the square root of 13 plus 8 times 1 over, here we have square root of 13 minus 1 times square root of 13 plus 1. It's of the form a minus b times a plus b, and it's equal to a square minus b square. So just a is equal to square root of 13, so a square is equal to square root of 13 square equal to 13, and b square is 1, so 1 square is equal to 1, so it's equal to 13 minus 1. So we are just applying the rule, so it's equal to 8 radical 13 plus 8 over 12. So now and the last example, so we have two numbers in the denominator. We will multiply it by its conjugate, so square root of 7, plus it will become minus square root of 10. So this is the conjugate of the denominator. The same for numerator. So 2 times square root of 7 equal 2 square root of 7. 2 times square root of 10 equal 2 square root of 10. Minus 7. Minus and minus equal to plus. Square root of 7 times square root of 10 equal to square root of 70. Over. So here we have a plus b times a minus b. It's equal to a square minus b square. So a square is equal to 7 and b square is equal to 10. So a square is equal to 7 minus 10. So here we have the numerator is the same and the denominator is 7 minus 10 equal to minus 3. So we have no square root in the denominator, so it's rationalized. Hope it's clear. Goodbye.